Hi, I'm Nadia Fray, and that's my partner.
Nadia, Feliciano.
And we're going to show you some problems on integration by parts. This problem is the integral of arc sine x dx. And we're going to let u equal to sine arc sine x. And then du is 1 over square root of 1 minus x squared dx. dv is going to equal to dx, and v is equal to x. And then we just plug it into this formula up here, which is the integration by parts formula. So we have u times v, which is x times arc sine x minus the integral of v du, which is x over the square root of 1 minus x squared dx. And now we're going to solve for this part here. We could let u equal to 1 minus x squared, and then du is equal to negative 2x dx. We divide both sides by negative 2. And then we just plug it in. So we write the whole thing here. And now I'm going to take out the negative 1/2 and bring it out here. This becomes positive. Okay, and then we're going to solve for this part. So you could rewrite this as u to the negative 1 over 2 du. Which is equal to u to the 1/2 over 1/2, which is also equal to 2 times 5 over. Okay, and then we're going to just plug it back in and write the whole formula again. So x arc sine x plus this half is going to cancel out with this 2. Radical u. And now we're going to substitute back in u with 1 minus x squared. So x arc sine of x plus square root. Okay. Plus 1 minus x squared plus c. And this is your answer.
Now I'll be demonstrating the second problem. The integral of x cosine 5x dx. First you want to figure out what u, du, dv, and v is equal to. We're going to let u equal x. We're going to let du equal dx. dv is going to be equal to cosine 5x. And v, basically the antiderivative of this. We're going to do separately. So the cosine, integral of cosine 5x dx, we're going to use u substitution. U is going to be equal to 5x, and du is going to be equal to 5 dx, and we're going to divide 5 from both sides, making that these 5's cross out. It's going to be 1 over 5 du is equal to dx. So now we just rewrite this as the integral of cosine of u du, and then we have 1 over 5, which we're going to be moving over here. It's basically 1 over 5. Now this is a lot simpler to integrate. I'm going to move over here. The antiderivative of cosine of u is going to be sine of u. And I'm going to rewrite u as what it's equal to, and u is equal to 5x. So now that we know what v is, we know v is equal to 1 over 5 sine of 5x. We have all the parts, so we're going to use this formula right here. So basically u times v, which is u is equal to x, v is what we just solved for. It's going to be 1 over 5 sine of 5x. I'm going to subtract the integral of v, which is 1 over 5 sine of x, sine of 5x, sorry. And then du, which is equal to dx. So now what we can do is remove this 1 over 5, make it a lot simpler. So this would be minus 1 over 5, the integral of 5 sine 5x dx. This is the same situation that we came to before, right over here. So we're going to have to use u substitution again. We're going to let u equal 5x and du equal 5 dx. And then we're going to again divide both sides by 5. So this is going to be 1 over 5 times du is equal to dx. So now we just, same thing, we're going to get the integral of sine of u du, and we have the 1 over 5, we're going to bring it out. And what happens here is that this negative 1 over 5 is going to multiply with this 1 over 5. So we can rewrite that in the next step. I'll give you negative 1 over 25. And then if we take the integral over here, we're going to end up with negative cosine, and then we're going to change the u back to 5x. So now that we know what this is equal to, which is this, we're going to rewrite this. We're going to just add it right over here. This negative and this negative we're going to make a positive. I'll rewrite that in the next step. So I'm going to move over here. We're going to get 1 over 5x sine of 5x. And then again, these two negatives are going to change to positive, giving you positive 1 over 25. And then we have cosine of 5x. And plus c. Because there are no limits to the integral. And that is your answer.